This video is to explain how probability and odds or odds ratio are interrelated. And at the end of this video, I'm also going to show you how when you take the anti-log of logics, you get the exponentiated coefficients on the right side of the equation for a logistic regression. So, here are the formula for the probability and odds. As you can see, probability is just the total number of individuals having an attribute divided by the total number of individuals in a study. And odds is measured differently from probability. Odds is the ratio between individuals having that attribute divided by individuals without that attribute. Notice the difference in the denominator. So, now I'm going to show you the difference between probability and odds in an example. So, we will use underage drinking for this example. So, as you can see from the formula, the probability of being an underage drinker is the total number of underage drinkers in a particular high school divided by the total number of students in that high school. And the odds of someone being an underage drinker would be the probability of being an underage drinker versus 1 minus the probability of being an underage drinker. Notice the denominator here. This indicates the number of students without that attribute. In our example here, the attribute will be being an underage drinker. So, as you can see from this formula, the odds is the ratio of two probabilities. The numerator will be the probability of having that attribute, and the denominator would be the probability of not having that attribute. So, when the odds are greater than 1, it means that it is more likely for students to engage in underage drinking. Or odds greater than 1 can also mean that there's a greater chance for a student to engage in underage drinking in a particular school. So, if the odds is less than 1, it means it is more likely for a student to stay sober in that school. Or we can interpret that differently. When we see odds that are lesser than 1, it can also mean that a student has a greater chance of staying sober. So, when we see something like the odds equal to 1, it means there's an equal chance of engaging in underage drinking or staying sober. In other words, if you recall from the formula in the previous slides, the numerator are the number of people with that attribute. The denominator would be the number of people without the attribute. So, when we see the odds of something equals to 1, it means that there's an equal chance of engaging in underage drinking or staying sober. In other words, the probability of being an underage drinker is almost the same as the probability of staying sober. Remember the formula from here? So, let's look at another example. We all know, whenever we toss a coin, there's a 50% chance or a 0.5 probability of getting a head. And there's also a 50% chance or a 0.5 probability of getting a tail. So, the odds of getting a head, in this case, the attribute would be getting a head, would be the probability of getting a head divided by the probability of getting a tail, or 1 minus the probability of getting a head. So, as you can see, the odds of getting a head would be 1. And just know that probabilities can range from anywhere between 0 to 1. They cannot be below 0, they cannot be negative numbers or above 1. And odds can be anywhere from 0 to infinity. Because if you recall from the formula, the odds are the number of people having that attribute divided by the number of people without the attribute. So because of that, the formula for the odds can range from anywhere from 0 to infinity. And logistic regression is assessed using logics. Or to put it differently, logistic regression is expressed as the log of odds. This is what we mean by the log of odds, this formula here. The log of odds is also called the logic. And logic can range from anywhere between negative infinity to infinity. It's endless. The possible values or the possible range for logic or the log of odds are endless. It can range anywhere from negative infinity to infinity. And the equation for logistic regression can be represented as logic or the log of odds. And the formula for logistic regression can also be formulated as the anti-log, which means when you take the anti-log of the logic, this is what we have. As you can see from this equation, the right hand side is being exponentiated.